the ERC proof of concept is very different from a conventional ERC, like ERC Starting Grant, the Consolidator, or the Advanced. It's different because the timeline is shorter. It's a 1 year, 1.5 maximum grant, but the focus is very different. So the focus of the ERC proof of concept is technology transfer. So we can think of it as a push for innovation. And the other important distinction is, while everyone can apply for an ERC Starting Grant, Consolidator, etc., the proof of concept is only for ERC grant holders. Actually, ERC grant holders that have can get up to 3 proof of concepts during the duration of the ERCs. So it's a grant that lasts for 1.5 year. It is 150K, so it is a considerable rate, and it's meant to drive an idea that comes from fundamental research towards an application.
This is then related to the previous grant you won, and in this one, what are you looking to do?
The ERC proof of concept is called Highlight, the project. The ERC Starting Grant is MetaPower, and they have a common factor in between them, which is a material is called metasurfaces. Okay, here I have a macroscopic version. Try to picture this as something like 10,000 times smaller. Okay. But it's a type of nanomaterials where you can have very, very small nanopilars, and each of these can completely change all the properties of light. Okay, so imagine billions of these. Well, you can have a control of laser that is unprecedented. Now, what we are doing in the ERC Starting Grant, we are trying to develop these type of materials to control very intense lasers, to then focus this light in very, very small spots and trigger structured laser-matter interaction. So this is fundamental. It has its application, but the applications are on a long path. Like if you think about fusion, well, decades, okay? The challenge that one gets with applying for an ERC proof of concept is saying, I have this know-how, I can do these things. Is there something that I could bring to the market in a few years from now? And this is a little bit the path I went through in preparing the ideas for the ERC proof of concept. I thought, okay, we can control these intense lasers. What if instead of exerting this control in a very small spot in space and time, what if I use this to send laser really far? Okay. And this opened a little bit the idea of aerospace applications linked to metasurfaces.
In what ways does the Instituto Técnico help you towards this goal?
I believe that the ecosystem of innovation at Técnico is something that is moving, is evolving, is definitely something needed. And indeed, the creation of the Technical Venture Lab, which is something occurred only very recently over the last year, 2025, is bringing together the pool of founders, the pool of ideas, the pool of innovation, putting them together and trying to offer them advisors, offer them possibility of connecting with big companies, and also this on the underway, but a possibility of an incubation space. I believe that this is super important, that in a top engineering school like Técnico, that this is pushed further. And so initiative like the Technical Venture Lab and probably other that will come are very, very important to also retain the talent that we have around. Because often I get to the point of having students at the end of their master cycle and tell me, look, Marco, I'm considering to go abroad and living because I don't know, I want to have an impact in a startup, in a company, and there's just nothing around in this area. So the more we grow in this direction, the more we can retain the talent for which we worked hard for, and so it's going to be a very interesting environment.
What type of applications can you see, or do you foresee for these types of lasers?
Yes, the control that we can have for lasers, as I was mentioning before, can be used not only to deliver a lot of energy in a small space, but also very far. So for instance, it can be very interesting if we think of the laser shaping as a tool to deliver energy, for instance, to drones, we can use this energy to recharge them without the drones coming back to their base station. This can be very, very interesting and requires an exquisite control of light, because we only want to send the light efficiently to their photosensors. But also on top of that, we can also deliver information. We can make optical communication between satellites, again, kilometers and kilometers of distances, with information that's much better bandwidth than radio frequency communications. And so I really see that this intersection of photonics and aerospace is super, super exciting. And indeed, we have already a lot of interest among companies. There are already 2 big ones that signed letter of interest to be involved in this project. And so I can only be excited about this new opportunity that is opening up.
It's something that you've mentioned several times, this talent pool. And what type of advice would you give to these students that helps pushing this goal forward?
So to the students, I would say, first of all, that they can be the drivers of this innovation. So like in this case, what is coming from my lab and with my vision, but there's probably things that are going to be 10 times better just come purely from students. So and if we empower them with this possibility, they really want to stay. And I know, for instance, a lot is going on in Europe around this. For instance, ETH Zurich is now launching the ETH Startup Label. And when students come out, they graduated, they can still have this spin-off label, even though they're alumni. And this can be, and they get still some kind of good conditions. And then they're motivated to stay and create within that incubation environment something with impact. So I can only support and hope the technical will strengthen the support towards this type of innovations.
Professor, thank you very much. Thank you very much for the interview.
Thank you so much.